This is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I'm going to discuss about the different definitions as well as terminologies which are utilized in the multistage amplifiers as well as in the power amplifiers. So in this multistage amplifiers as well as in the power amplifiers, we are going to discuss about different classification of multistage amplifiers and different distortions appearing in the amplifier circuits. And in order to design the multistage amplifiers from the single stage amplifiers, what are the coupling schemes we are going to utilize? And what is the frequency response and analysis of the multistage amplifiers? And along with that, we are going to discuss the terms in cascade amplifier as well as Darlington pair. And we are going to see the terms a transistor, high frequency model, and hybrid model of common emitter, and F alpha, beta, and unity gain bandwidth products. And along with that, we are going to discuss about what is meant by differential amplifiers and what are the different types of differential amplifiers and the types of power amplifiers and how we can differentiate different power amplifiers by using their conduction angles. So the terms which are going to utilize in these multi-stage and power amplifiers, we are going to discuss in this particular session. So here, before going to the multi-stage amplifiers, first of all, we have to know what is meant by coupling. So coupling is nothing but it is the interconnection of two or more stages here. So the basic purpose of multi-stage amplifier is to cascade the two or more number of single stage amplifiers to make it as the multi-stage amplifiers. So to make multi-stage amplifiers, coupling is important here. And list various coupling schemes. Here we are going to utilize three types of coupling schemes, that is RC coupling, transformer coupling, and direct coupling. Next, why multi-stage amplifiers are preferred over single stage amplifiers here. So in the case of multi-stage amplifiers, in the multi-stage amplifiers, we are having input impedance is very high as well as output impedance is also very high. But in the case of single stage amplifiers, we are having only input impedance is high and output impedance is low. And these multi-stage amplifier applications can be used to increase the extremely weak signals to utilizable levels. That is nothing but the power, current as well as voltage levels from the multi-stage amplifiers are very high compared to the single stage amplifiers. And the distortion can be reduced by changing the signals within the different stages in the case of multi-stage amplifiers. So that's why multi-stage amplifiers are preferable compared to the single stage amplifiers in the practical applications. And next we will see what is meant by frequency response or define frequency response. So here frequency response of any particular system or amplifier, it describes the behavior of the system at various frequencies of input signal. That is nothing but at one particular frequency signal, how much gain we are getting. At another frequency range of signal, how much gain we are getting. That is nothing but at different frequencies, how the response of the amplifier we are getting, we can able to indicate by using frequency response of that particular amplifier. And next, what is the use of low frequency analysis? So this low frequency analysis is one of the type of AC analysis. While doing this particular analysis, we have to ground the DC signals as well as all the capacitors which are present in the amplifier circuit. And this is used to know the behavior of the system at low frequencies of the signal, and also it helps to find the lower cutoff frequency of the amplifier or circuit here. And next one is define lower cutoff frequency. See, the lower cutoff frequency of the signal at which the gain of the system drops by 3 dB from its maximum value. Suppose in the if we take frequency versus gain curve, in that the gain is, suppose initially it is at unity gain or at some particular value, and after that it is rolling off or it is decreasing. So the frequency whenever the gain is drops by 3 dB of this maximum value, suppose somewhere here it is. So this particular frequency we are calling it as the lower cutoff frequency, FL or F1 we can indicate. And next, what is the effect of coupling and bypass capacitors at low frequency? So at low frequencies, the coupling as well as bypass capacitors offers very few reactance here, very small amount of reactance here. Due to this reactance, there is a reduction in the gain of the system at low frequency signals. So at low frequencies, due to the low reactance of the signal, at low frequencies, the reactance of the capacitor is high here. That is nothing but the reactance of the capacitor is C equal to 1 by 2 pi Fc here. So as frequency is low means the reactance is very high. Once the reactance of the capacitor is very high means it cannot able to allow the AC signal through it. So because of that, there is a reduction of gain in the system. And next, define bandwidth of an amplifier. So bandwidth is defined as the range of frequencies allowed by an amplifier to produce undistorted amplified output. That is nothing but at what frequency range of signals that particular amplifier can able to provide the faithful amplification and without providing any noise and distortion indicates the bandwidth of that particular amplifier. Next, what is gain bandwidth product? So this gain bandwidth product is nothing but figure of merit. So gain bandwidth product, we can also call it as figure of merit, and it is the multiplication of gain as well as bandwidth of particular amplifier circuit. And next, what is multistage amplifier? So an amplifier consisting of more than one internal amplifier stage is called as multistage amplifier, and if we interconnect or if we cascade more than one number of amplifier stages, so that we can call it as multistage amplifiers. And next, what is RC coupling here? So in the multistage amplifiers, if the connection is made between two adjacent stages in system through the resistor and capacitor network, then that particular type of amplifier is known as RC coupling amplifier, and that particular type of connection is known as RC coupling here. So in that case, we are going to utilize resistors and capacitors in order to interconnect two intermediate stages. And next, what is LC coupling? So in the multi-stage amplifier, if the connection is made between two adjacent stages in a system is through the inductor and capacitor network, then that particular type of connection is called as LC coupling here. That is nothing but suppose we are having one particular amplifier circuit. I am taking CE amplifier circuit here. This is the first stage I am taking, and the second stage of this one I am connecting through the resistor and capacitor to the next stage. This is the second stage. Here we are giving Vin, and here we will take the output. This is ground, and these two will connect it to common supply. So this is the LC network in order to cascade this first stage as well as this second stage. And next, what is transformer coupling? So transformer coupling is nothing but in the multi-stage amplifier, when we wanted to interconnect two internal stages, if we utilize the transformer as the coupling element, so that it is the transformer coupling here. So here in this particular circuit, if we replace this LC circuit with the transformer, so that it will become the transformer coupling here. And next, what is direct coupling? So direct coupling is nothing but in order to interconnect two stages in the multi-stage amplifier, we are directly connecting output of one stage to the input of the second stage directly without interconnecting any elements between the stages. So this type of connection, we can call it as the direct coupling. And next, what is cascading? The cascading is nothing but a process of connecting two similar stages such that the output of preceding stage is connected to the input of the next stage is called the cascading here. So in this cascading process, we can utilize any elements, resistors, inductors, or capacitors, or transformers here. Next, what is Darlington amplifier? So Darlington amplifier or Darlington pair is a two transistor that acts as single transistor but within a much high current gain. So this Darlington amplifier is nothing but the combination of two transistors, but we are representing it with the single transistor with very high current gain here. That is nothing but a small amount of current from a sensor or from microcontroller, or can be used to drive a larger load here. And next, define distortion. So distortion is nothing but change of output wave shape from the input wave shape of the amplifier. Here actually, what is the basic function of the amplifier here? What is the signal we are providing across the input of the amplifier? The same signal should appear across the output, but the amplitude of that particular signal should be increased. But the remaining parameters should be same across the output of the amplifier. But if the distortion is present in the amplifier, means the shape of the waveform we will not get in this way here. Okay, so this an amplifier that has lesser distortion produces a better output and hence consider it as the efficient one. If less amount of distortion is present in the amplifier, means that is not affecting that much to the output signal, but very high amount of distortion is present across the output, means we will not get this proper amplified output across the amplifier. And next, define push-pull configuration. So here push-pull configuration is one of the type of class A amplifier. So if the class A amplifier by using combination of transistor pair called as push-pull configuration here. So in this case, we are going to utilize two transistors and one transformer. So depends upon the applied input signal, any one of the transistor will be active and that will provide the output. So that's why we are calling it as the push-pull configuration. And next one is define large signal amplifier. So these large signal amplifiers are also called as power amplifiers. Okay, the main intention of this large signal amplifier is to deliver the large amount of power to the load, that is nothing but power to the different applications here. Small signal amplifiers are nothing but the voltage amplifiers and large signal amplifiers are nothing but the power amplifiers. And next, define power gain. So the power gain is nothing but it is the ratio of output power to the input power of any device here. So gain, the power gain, we can write it as PDC by PAC of particular device. And next, define class A power amplifier. So amplifier that conducts the collector current for a full cycle of the input signal is called the class A power amplifier. So the conduction angle of class A power amplifier is 360 degrees. That is nothing but it is going to utilize total input signal for amplification here. And next one is define class B power amplifier. So a power amplifier that conducts the collector current for half cycle of the input signal, that is nothing but it can able to conduct 180 degrees of the input signal. It is going to utilize only half of the input signal for the amplification purpose. And next, define class AB power amplifier. So in this case, a power amplifier that conducts the collector current for more than half cycle of the input signal. That is nothing but almost it is greater than 180 degrees but less than 360 degrees. So it is the compromise between both the class A amplifier as well as class B amplifier. That is the class AB amplifier here. So that's why the conduction angle is greater than 180 degrees and less than 360 degrees. So always it is in between 180 to 360 degrees range. And next, define class C power amplifier. A power amplifier that conducts the collector current for less than half cycle of the input signal. That is nothing but if it is going to utilize less than 180 degrees of the input signal for the amplification, that particular amplifier we can call it as the class C power amplifier. And next, define efficiency of power amplifier. So the efficiency of the amplifier is nothing but it is the capability of the power amplifier in converting DC power to AC power here. So how much it can able to converting, how much efficiently it is working is indicated by the efficiency of that particular amplifier. Next, what is a push-pull amplifier? So a push-pull amplifier is an amplifier which has an output stage that can drive a current in either direction through the load. In both the directions, it can able to drive the one particular application here. And next, what are the applications of power amplifiers? So these power amplifiers we can utilize in the public audio system. That is the major application of the power amplifier here. And next, list the various distortions in the power amplifiers. Here we are having three types of distortions we can expect in the amplifier circuits. That is the nonlinear distortion. We can also call it as amplifier distortion, and frequency distortion and phase distortion. And next, define gain bandwidth product of an amplifier. So the gain bandwidth product is a figure of merit and it is defined as the product of mid-band gain or upper 3 dB frequency FH, that is gain as well as upper 3 dB frequency. The multiplication of the two indicates the gain bandwidth product. And next, define AC input. The AC input circuit is defined as a sinusoidal signal with certain amplitude as well as frequency. So any AC signal with some certain frequency as well as amplitude indicates the AC input. And next, define DC input. So the DC input circuit is defined as the biasing voltage to the transistor amplifier. What are the biasing voltages as well as the supply voltages we are providing for the amplifier is indicated by the DC signal or DC input here. And next, what is a power transistor? Okay. A transistor that is manufactured to suit the purpose of power amplification is called as power transistor. That is nothing but a particular transistor can able to amplify the power signal is called as the power transistor. Next, define voltage amplifier. So voltage amplifier is to improve the strength of the voltage or improve the voltage of that particular signal. So a voltage amplifier is designed to achieve the maximum voltage amplification. So how we can able to indicate the voltage amplification means the voltage gain of that particular amplifier, that is beta into RC by Rn. We will indicate with the beta into RC by Rn, that is the current amplification factor in that amplifier into collector resistance by input resistance. And next, define power amplifier. So power amplifier is used to amplify the power level of the input signal, and it is also required to deliver a large amount of power, and in order to handle the large amount of current, that is nothing but in order to drive the large applications, we can able to utilize this power amplifiers. What is audio power amplifier? So the audio power amplifiers are used to improve the power level of signals that have audio frequency range, that is the signals within the range from 20 Hz to 20 kilohertz range can be able to amplify by using the audio power amplifiers. So these are also known as small signal power amplifiers. Why? Because the frequency range is up to 20 kilohertz only. And next, what is radio power amplifier? So radio power amplifiers are also called as tuned power amplifiers, are used to amplify the power level of the signals that is having the frequency range 3 kilohertz to 300 gigahertz range. So these particular range of signals can only be able to amplify by using radio power amplifiers. These are also called as large signal power amplifiers. And next, defined power dissipation capability. So the power dissipation capability, we can define here it as the ability of a power transistor to dissipate the heat developed in it. That is nothing but the heat developing in that particular transistor, how it is dissipated. So metal cases called heat sinks are used in order to dissipate the heat produced in power transistors. By utilizing the heat sinks, we can able to dissipate the heat generated in the power amplifiers. And next, define collector efficiency. So the collector efficiency is nothing but when the DC supply is given by the battery, but no AC signal input is given to the amplifier. In that case, the collector output at that particular condition, we can say it as the collector efficiency. That is nothing but whenever we are not providing any AC input signal to the amplifier, and the amplifier itself, it is providing the collector current, that is nothing but we can say it as the oscillator circuit. So in that oscillator circuit, how much collector current we are generating is indicated by the collector efficiency. And next, to define frequency FT here. So the frequency at which the magnitude short circuit current gain of CE amplifier reduces to unity is defined as the frequency FT here. That is nothing but whenever the gain is at 1, at that instant how much frequency is there, that particular frequency we are calling it as the FT frequency. And next, what is DC supply? So DC is nothing but the direct current. It is referred to power system that use only one polarity of voltage or current, and to refer to the constant or zero frequency is called the DC supply. And what is mean by AC supply? AC supply is nothing but the alternating current is an electric current which periodically reverse direction in contrast to direct current which flows in only one direction. So the DC level we will indicate with like this. The AC supply we will indicate in both the directions, in the positive direction as well as in the negative direction. And next, what are the advantages of multi-stage amplifiers? So in the single stage amplifiers, the amplifier parameters, that may be current gain, voltage gain, input output impedances, they may provide. But if we interconnect that single stage amplifiers, we will get the multi-stage amplifier. In that multi-stage amplifier, the gain will be more compared to the single stage amplifiers. Why? Because in the multi-stage amplifiers, when we are interconnecting the stages, the gain is multiplying here. Suppose if I am taking 3 stages in the multi-stage amplifier, so the overall gain of this one is the gain of first stage into gain of second stage into gain of third stage. That is nothing but the overall gain is the multiplication of all the individual stages gain. So that's why gain will be improved in the case of multi-stage amplifiers. And improve quiescent point or operating point. So the operating point is improving means there is no variations in the operating point. That is the value of IC as well as VC. The variation is less here. Anyway, VC is nothing but the supply voltage VCC. So it is constant only. But the value of IC may vary due to the beta value as well as the temperature value. But these variations are less in the case of multi-stage amplifier. So that's why there is an improvement in the Q point. And next, improve input impedance depending upon the input stage and also the output impedance. And it will provide very high bandwidth compared to the single stage amplifiers. So these all are the advantages of multi-stage amplifiers over the single stage amplifier. And next, what are the disadvantages of multi-stage amplifiers? So compared to single stage amplifiers, bandwidth of multi-stage amplifier is low in some applications, but in some applications it is providing the high bandwidth only. And it is complex. Why? Because we are cascading many number of single stage amplifiers. And because of interconnecting all the stages, the number of components are increasing here. So the cost of the system will also increase here. So these are the disadvantages of multi-stage amplifier. And next, what is the role of coupling capacitor Ce in amplifier circuits? So the role of the Ce is to couple the AC signal, whatever we wanted to give for the amplifier circuit. It will couple the AC signal to the base of the transistor here. Suppose this capacitor is not present in the amplifier circuit, the signal, whatever the signal we are providing to the amplifier will be coming parallel to the resistor R2, and the bias voltage of the transistor base will be changed here. That is nothing but we are taking one particular amplifier circuit here. For this amplifier, this is RC, RE, R1 and R2. We are coupling the AC input signal through the coupling capacitor Ce in here through this. So if this particular capacitor is not present here, means this is combining with this R2 resistance and the biasing provided for this base of this transistor will be changes here. If the biasing voltage is changing, means obviously the output signal will also change here. So Ce allows the AC signal from source to flow into the input circuit without affecting the bias conditions to the base of the transistor. So that's why coupling capacitor, input coupling capacitor is must for the amplifier circuit. And next, what is the role of emitter bypass capacitor Ce in amplifiers? So this emitter bypass capacitor will be available here, Ce. So the emitter bypass capacitor Ce is connected in parallel to the emitter resistor. So it offers very low reactance part to the amplified AC signal. Suppose this capacitor Ce is not present, means the voltage developed across the emitter resistance again will feed back to the input of the amplifier, so that the output level will be reduces here. The output voltage will be reduces here. So if this is present, means the amplified AC signal will pass through this directly without reducing the output voltage or signal. And what is the role of coupling capacitor Cc in amplifiers? So this coupling capacitor Cc is coupled that connects the output signal to the that connects the output signal to the next stage, and it will prevents the DC interference between the stages and controls the operating point from shifting here. So these are the basic function of the coupling capacitor. It is also called as blocking capacitor. Why? Because it does not allow any DC voltages through it. And if this is not present in the amplifier circuit, the collector resistor will come in parallel with this resistance R1 of the biasing network, so that for the next stage biasing resistance or biasing voltages will be changes, so that the overall output of the multi-stage amplifier will be changes here. So in any amplifier circuit, the input capacitor, coupling capacitor and emitter bypass capacitors are mandatory to get the faithful amplified signal. And next, what are the advantages of direct coupled amplifier? So in the direct coupled amplifier, though we are not utilizing any coupling elements, so it is a very simple circuit with the resistors only we can implement this. And the cost of this one is also very less. Why? Because we are not utilizing any coupling elements here. And next, what are the disadvantages of direct coupling here? So while coming to the disadvantages, it cannot be used for amplifying the high frequency signals here. That is the major drawback of the direct coupling amplifiers. And the operating point is also shifting due to the temperature variations in the circuit. Why? Because we are not providing any coupling elements to control that variations. So that's why we can expect we can expect the variation of operating point in the amplifier. Next, what are the applications of direct coupled amplifier? So this can be useful for the low frequency amplification as well as low current amplification of the signals. And next, what are the advantages of RC coupled amplifier here? So while coming to the advantages of RC coupled amplifier here, the frequency response of RC coupled amplifier provides constant gain over a wide frequency range. So that's why it is suitable for all audio frequency applications. Okay, it is audio frequency amplifier, we can call it as. And this circuit is very simple and the cost is also less, because the coupling elements are resistors and capacitors only. Those are available with less cost only. And it becomes more compact with the upgrading technology. Nowadays, we can implement these with very small space and with very small, very less cost and with a very high speed. And next, what are the advantages of RC coupled amplifier? So while coming to the advantages of this one, the voltage and power gain are low because of the, this is the applications of the amplifier. What are the applications of RC coupled amplifier? So here the voltage and power gain are low because of the effective load resistance. They become noisy with age. And due to poor impedance matching, power transfer will be low in the case of RC coupled amplifiers. And what are the applications of RC coupled amplifier? So they can able to provide excellent audio fidelity over a wide range of frequency. And most of the cases we can utilize for the voltage amplification, and it will due to poor impedance matching, RC coupling is rarely used in final stages. In most of the cases we will not utilize RC coupling in the final stage. Mostly we will prefer the transformer coupling in the final stage to provide the impedance match. And next, what are the advantages of transformer coupled amplifier? So mostly the basic advantage is impedance matching between the two stages. We will utilize this transformer coupled amplifier, and it is providing very high gain, and there is no power loss in collector and base resistors in the transformer coupled amplifier, and it is efficient in operation. What are the disadvantages of transformer coupled amplifier? So even though it is providing a very high gain, but it is varies constantly with the frequency here. Gain variations will be high here. So because of that, the frequency response provided by the transformer coupled amplifier is very poor, and the frequency distortion is also very high because of variations in the frequency, and transformer always produce the hum noise, and it is very bulky and costly. And what are the applications of transformer coupled amplifier? So the best application is for impedance matching and for power amplifications, and wherever the power transfer is needed in that particular case, we can utilize this transformer coupled amplifier. And next, what is mean by Darlington pair? So this Darlington pair consists of two bipolar junction transistors. Those are connected in such a way that the current amplified by the first stage, okay, that is connected to the second stage again. So the overall current gain is to the multiplication of the two gains provided from the two stages. So whenever we wanted very high gain in that particular case, we can utilize this Darlington pair. So in the Darlington pair, the current gain HFE is the current gain of the first stage as well as the current gain of the second stage, so that we can able to improve the overall current gain. And next, what are the advantages of Darlington pair? So here the basic advantage is it will improve the current gain and also the input impedance of the circuit, and it is available in single package instead of two interconnection of two transistors. With the single transistor, we can able to design this Darlington pair, and this configuration is very easy and very simple. And what are the disadvantages of Darlington pair? So here switching speed is slow. Why? Because always the second stage should wait for the first stage output, and the bandwidth provided by this one is very less, and base emitter voltage is very high here. Always we need to provide very less base emitter voltage to get the amplified output across the amplifier, but it requires very high base to emitter voltage because of the cascade of two similar transistors. And saturation voltage is also high, which can lead to high level of power dissipation in the particular applications. So power dissipation also high in this case. And next, what are the applications of Darlington pair? So this can be utilized in the power regulators and in the audio amplifier output stages, and in the display drivers, and in the motor controls, in the touch and light sensors, and in the solenoid control circuits. And what is mean by amplitude distortion here? So the amplitude distortion is due to the production of harmonics in the output. That is nothing but generally in the output of the amplifier, we need to get the signal like this. But instead of getting the signal like this, we are getting the output like this here. Along with the required signal, we are getting these particular harmonics. So this indicates the amplitude distortion here. So because of this amplitude distortion present in the circuit, there is a compression of the positive half cycle. That is nothing but some amount of positive half cycle may be reduced here, and there is the expansion of negative half cycle. So there is the extension in the negative half cycle may happen here. In some cases, some amount of information or waveform will be clipped off here. Okay, so actually why this amplitude distortion is occurring in the circuit means due to the non-linear nature of the transistor dynamic characteristics, this amplitude distortion is occurring in the circuit. So because of this, we are getting the undesired signal along with the desired amplified version of the output signal. And next, what is meant by frequency distortion? So this frequency distortion is due to the different frequency components of an input signal are amplified differently. That is nothing but along with the required frequency signal, some other frequency signal is also amplifying, and both will appear at the same time across the output. so that we cannot able to estimate which one is the required signal here. So the factors which are contribute to this type of distortion are the device capacitances and the reactive components of the associated circuits. So if we are able to maintain the proper capacitance value as well as proper reactive components of the circuit, we can able to rectify this frequency distortion in the amplifier. And next, what is mean by phase distortion? So the phase distortion is due to the unequal phase shifts of the signal of different frequencies. So this is occurring, actually this particular distortion is depending upon the phase angles of the complex gain of the amplifier on frequency. So these phase shifts are also due to reactive effects and the active devices. So generally this phase distortion will cause problems in the TV picture description. If the phase distortion is occurring, means we cannot able to see the picture in the television properly. So to avoid this, the amplifier phase shift should be proportional to the frequency of the applied input signal. If we maintain in this particular ratio, we can able to reduce the phase distortion. So in this session, we have seen different terms which are utilized in the multistage amplifiers as well as power amplifiers.
Like, share and subscribe. Hit the bell icon for more updates.